Hey, welcome back to Stewart Science. Today we're going to be talking about the parts of an experiment. When you do an experiment, when you do a scientific investigation, what are the pieces of the puzzle that you'll be looking to put together to get a good relationship between two variables? So there are three big buckets of things that can change in an experiment. So anything that could change in an experiment is called a variable. It's anything that could be different from trial to trial to trial. Now, the vast majority of those parts of an experiment need to fall into the first bucket, which is a constant. Another name for that would be a controlled variable. These are all the things in your experiment that don't change from trial to trial to trial. They're things that you keep the same on purpose. Because if you change them, they're what's called a manipulated or an independent variable. That's the one thing that you change when you're looking for that relationship. The problem is that if you have more than one thing that you change, you don't know which of those things is responsible for the outcome of your experiment. And the outcome or the results or whatever you measure, that's called the responding variable. Another name for that would be a dependent variable. Those are your measurements. So in a good experiment, you should have tons and tons and tons of controlled variables or constants. You should change only one thing, and that's your manipulated or independent variable, the thing that you're adjusting. And then the thing that you're looking at to see how it responds or reacts, that's your responding or dependent variable. You've probably heard those words independent and dependent before. I use manipulated and responding because independent and dependent kind of sound similar, which confuses a lot of people. So let me give you an example here. Let's say you're doing an experiment to see how changing the temperature of water affects how quickly an ice cube melts. You're going to want to keep a lot of things the same. You want to keep the same amount of water in each cup. You want to keep the same size ice cubes. If you're measuring temperature, you want to use the same thermometer so that if you change all those things and one ice cube melts faster, you don't know if that's because you used a tiny ice cube or you used more water. You just don't know which of those is responsible for your result. So in that case, changing temperature to see how the melting time responds. Temperature is what you're changing, so that's your manipulated variable. And then the thing that you're measuring, or your dependent variable, is the time it takes that ice cube to melt. Everything else, the ice cube's temperature, the water temperature, the size of the ice cube, the size of the glass of water you're using, you can probably name 50 other things. Those are all should be constants that you keep the same. Now, let me give you an example of something you might see on a test or a quiz down the road. Here's a question. It says, Miss Johnson wanted to test how her baby's weight changed over time. So she weighed her baby on the first of every month. She used the same scale, and every time she measured, the baby was only wearing a diaper. What I want you to do, you're going to now undo this, but listen to me right now. Go find some scrap paper and a pencil and pause this video. And I want you to write down independent or manipulated, responding or dependent, and then find all the control variables you can. You should have one manipulated and one responding variable and at least 4 controlled variables. Pause it right now. Okay, so here's what you should have had. For your controlled variable, these are all the things that don't change from trial to trial to trial. The things that Miss Johnson kept the same. She tested the same baby. It was her baby every time. She didn't go grab someone else's kid and weigh them. That's not the experiment. The experiment is, how does her one baby change over time? She weighed her baby on the first of every month. She didn't weigh in the middle of 1 month and then 2 weeks later. She let the same amount of time go by between each data point. She used the same scale. So she didn't use the kitchen scale on one, the bathroom scale on the other, and the doctor's office scale. She used the same scale every time. And she measured the baby only wearing a diaper. She didn't put on its heavy coat or all its clothes or something, or let it, just sit there naked. She put the same exact outfit on the baby, so the baby's clothes didn't impact the weight of her baby at that time. So those are all your control variables. There's 4 for you right there. Her manipulated variable, or the one thing she changed, was time. She was looking for how her baby's weight changed over time. As time changed, that's what she allowed to change. She's looking at weight. So time is the independent or manipulated variable, and then that would make the baby's weight the responding. That's what she was measuring. She put the baby on the scale, and whatever the scale said, that's what her data point was. So that's her responding variable. So to wrap things up here, manipulated variable is the one thing you change. You can only have one, because if you have more than one, you don't know which one is responsible. Responding or dependent is the result, what you look at to see how it reacts. And then everything else, as far as it depends on you, should be kept the same from trial to trial to trial. Those are called controlled variables. That was Mr. Stu, and as always, keep learning no matter what.